This is chapter 4, physics part of class 9, describing motion around us. See, every object almost around us are in a state of motion, be it astronomical objects or be it subatomic particles. So we need to study about different types of motion. When we talk about moving objects, we always need something which is known as a reference point. That means with respect to a reference point, something is changing its position. So, how do we know that an object is moving? So, with respect to a reference point or a fixed point, if the object is changing its direction, then we will say it is in a state of motion. So this reference point is a fixed point, and at this point the object is said to be at rest. And if it is in motion, then there is a change in the I will say position of the object. So we are going to study about motion in a straight line where an object moves in a linear form of motion. Here we can see swimmers moving in a linear form, a car moving in a straight line, then a fall of a basketball when it is basket is done. So it is a straight line motion. A train is moving in a straight line. So figure 4.1 shows different objects moving in a straight line. Now, we move to the next part. Let us take the example of an athlete running on a straight track. So this is also a linear motion, an example of a linear motion. To describe the position of Nina, this is Nina, an athlete. Let us take her starting point as the reference point. Now, if I take reference point as the origin O, so this is my starting point. This O is my starting point. The athlete starts running from O, and her positions at two instants of time are marked by positions or points B and point A. So somewhere here there is B and A. Now, when I say at an instant, that means there is no time gap. At a particular time, we are talking that it is known as instant of time. That means at a particular time. But if I say there is a time interval, that means there is a time gap. Say T1 to T2, there is a time gap. And that time gap is known as time interval, T2 minus T1. So at a particular instant, the positions are B and position is A after it starts from O. To describe the position of an object, we also need to specify its direction. So when I am talking about Nina, an athlete, starting her motion, then we can say this is the direction from O to A, O to B to A, or I can say from O to A via B, right? So for object moving in a straight line, the object can move only in one of the two directions. Either the object is moving forward or it is moving backward, right? Now in this case, it is moving forward. The direction is represented by plus for forward motion and minus for backward motion. Plus for forward motion, minus for backward motion. That is the negative scale. Now, distance traveled and displacement. Let us realize what is the difference between distance traveled and displacement. Now, suppose an athlete starts running from point O. This is the starting point. Reference point O at time t is equal to 0. So, this is the initial time, and reaches point B reaches point B at t is equal to 4 seconds. So 4 seconds is the instant, 0 second is the instant, and the time gap is 0 to 4 seconds, and reaches point A at t is equal to 10 seconds, then runs back along the same path till point B. That means it is moving from O to A and runs back from A till point B, reaches there, runs back along the same path till point B, reaching there at 16 seconds. Right? How much is the total distance traveled by the athlete between the starting and stopping position? So, starting position is O and stopping position is B. But stopping position is B means the athlete has traveled distance OA and again AB. Then only B is the final stopping position. So the total distance traveled is OA, which is 100 meter, and AB. Here we can see AB means 100 minus 40, which is 60 meter. So this much distance is 60 meter, and OA is 100 meter. So it is 100 meter plus 60 meter, that is 160 meter is the total distance traveled. That is the real path covered. Now let us think about the distance between the starting and the stopping position of the athlete. Now if the athlete moves from O to A and back to B, now what is the real distance between O and B? That is 40 meter. That is OB is equal to 40 meter. Now this is your final point. B is the final point. Now the difference between the starting and the final position is 40 meter irrespective of the path covered. And so this is the displacement, the magnitude of the displacement. Now remember, displacement is not only the magnitude. So displacement is the net change in the position of the object between the two given instants of time. So what is the change in the position? Change in the position is from O to B. So a complete description of the physical quantities like displacement requires what? It requires direction as well as the value, which is the magnitude. The value is known as the magnitude. And here the magnitude of the displacement is 40 meter. Now the direction of displacement is specified from the position at the first instant towards the position at the second instant. So here we can see that if it is 40 meter, then it is 40 meter in the positive direction because it is on the right hand side. It is 40 meter in the positive direction. So this is the displacement, and total distance covered is how much? Total distance is 160 meter. Okay, so here we can see that between t is equal to 0 to t is equal to 16 seconds, total distance covered is 160 meter. But the displacement is actually the distance between the starting position and the final position, which is 40 meter. And where is the direction? It is in the positive direction towards right hand side. So this is the basic difference between distance and the displacement. Distance is the real path covered, the total path covered. and displacement is the shortest path covered, or rather the shortest distance between the starting position and the final position. Moreover, keep in mind that displacement requires the direction, not only magnitude but also the direction. So displacement is a vector quantity. Why it is a vector quantity? Because it needs both direction and magnitude to specify. But distance is a scalar quantity. Why? Because only the true path covered is required here. That's why it is a scalar quantity. So this is the difference between distance and displacement. Now, for a motion in a straight line, the total distance traveled and the magnitude of the displacement are equal if the object moves without turning back. That is, if it moves in the straight line. Had it been moving from O to A, then the distance and the displacement both would have been 100 meter. Now after moving to A, it is again coming back to B, which is having a distance between A and B is 60 meter. So the real path covered is from O to A and again from A to B, which is 100 plus 60, that is 160. But when you talk about displacement, it is this. The displacement means the difference between the starting and the final position. So here, if there wouldn't have been any backward movement, then the distance and the displacement would have been the same, right? Because there both the objects, both distance and displacement would have the same value. Now activity 4.1 as shown in figure 4.5. So let us see which one is 4.5. This is your 4.5. As shown in this figure, a ball is thrown vertically upwards from O. So it is thrown vertically upwards from O and it moves up straight till B. This is B, the highest point, and then falls back to O again. So can you consider this to be a motion in a straight line? Of course it is a motion in a straight line. For this motion, what all things you are supposed to fill up? See this. When the position is O, total distance travelled by the ball from O till that position is 0. Displacement is also 0. Now when it is A, now see two lines are shown just for clarity. Now O to A is to B is upward motion. B to C to O is downward motion. Right? So this is what it is. How? So if it is at A, then total distance traveled by the ball is how much? The distance between O and A is 40 centimeter. Displacement will also be that because it is in the same straight line. It's not moving backwards. Now at B means I have to reach the highest 140 centimeter. So this is 140 centimeter. Displacement will also be 140 centimeter because it is in the same straight line. There is no change in the direction, right? So that is also 140 centimeter for B. Now here let me see, for B is done. Now C means this much. Okay, now distance will be how much? Distance will be O to B, that is 140 plus how much? Plus coming from 140 to 80, that is 60. So 140 plus 60 centimeter. This will be the distance travelled. Displacement is the gap between, the difference between the two positions O and C. So this case it will be 80 centimeter. Now since it is moving backwards, it is changing. The value is changing. Right? Now C position O. For O, the total distance travelled by the ball from O till that position, that means it is moving O to B, which is 140 and again coming back again another 140. That is the total distance traveled. If it is moving from O to B and B to O. But displacement is again 0. 0. Okay. So analyze the data filled in this table and choose which of the following is true for displacement. It can never be 0. Is it? We are seeing displacement, so this is false. Its magnitude can be greater than the total distance traveled. We did not see that, so this is again false. Its magnitude is less than or equal to the total distance traveled, that we have seen. It can be equal to or it can be less. Its magnitude is less than the total distance traveled in all cases. No, not at all. Not in all cases. Now, in the example of an athlete running back and forth on a straight track, the previous case, when will the displacement of the athlete be 0? Obviously, if the athlete is returning to the position, say if it has started from O to B and returns to O, then only it will be 0 displacement. And what will be the total distance traveled? Total distance traveled will be twice the track. That is OB plus again BO, or you can say twice OB will be the total distance. This will be the distance. So if we have the value, we can see over here the value. Yes, it is 0 to 100. So it is twice the 100. 200 meter will be the distance and displacement will be 0 in that case. Now, fuel used up in a vehicle depends on which of the following? Whether it depends on the displacement or it depends on the total distance traveled. Obviously on the total distance traveled. So if you go to school from home and then you return to your home, will you not need any fuel? You will say, no, my displacement is 0, so I don't need any fuel. Is it possible? No. To move from home to school, you need fuel. From moving from school to home, again you need fuel. So fuel used up by the vehicle actually depends on total distance traveled. Now, let's see. A ball rolls down an inclined track as shown in figure this thing. Okay, as shown in figure 4.6. This is rolling down. The ball is rolling down as it is shown in figure 4.6. Now what happens in this motion? Is this motion a straight line? Of course, it's a straight line motion. Of course, assuming the starting point of the ball to be O, that is the origin, can its motion from O to D be depicted using a horizontal line as it is shown? So using a horizontal line, it is not possible, but its straight line motion in an inclined pathway is possible, right? So here let me see. Next, are the values of total distance traveled and magnitude of displacement from O equal or different at positions A, B, C, D? Okay, let us see. Now, in this case, if I say it is moving at position, say A, at position B, at position C, and at position D from O. So, OA, how much it is covering up? 40 centimeter. So, distance and displacement. Okay, distance and displacement. Let me put C and D here only, then it will be easy for us. So, distance covered till A is 40 centimeter. Displacement is also 40 centimeter. B 50 centimeter, here again 50 centimeter. C again 40, 50, 60, 70, right? So this is 70 centimeter. Again it is 70 centimeter. Till D it is how much? 100 centimeter. And over here it is again 100 centimeter. So in each case we can see the distance and the displacement are the same. Why at every point it is same? Because they are not, the body is not changing the direction. It is moving in the forward direction and not in the backward direction. So at each point, the distance and the displacement is the same.